So continuing on with this problem right here, we'll then okay. So based on these values, 10 tooth sprocket, 60 tooth sprocket, there's the pitch. If that's the center to center distance that we want between these two sprockets, then we'd have to have a length of chain equal to 26.609. Well, that's not evenly divisible by 3/4 of an inch, so we wouldn't be able to make a chain that long. So let's take 26.609 and let's divide it by 0.75, and we get 35.479. So that would be the number of pairs of links. So we could go up to 36 pairs, right? So 36 times 0.75, 27 inches. So if we had a chain with a 27-inch length, then we could go ahead and calculate the center to center distance. And when we build our sprocket box, maybe like on a CNC machine or something where we're going to have the box that will hold the bearings, we can get a very accurate distance between those two. Oh, and I just happened to, I'm going to make this a different number. All right, so 23. So that didn't change this because we were solving for the length. So now we would, if you got that value and want to try that one, so we would go back here and put in 27 and then calculate the center to center distance that corresponds to that length. So I'll just put in CC, and there's the distance. So the distance between our axles with these types of sprockets and this pitch of chain and that length of chain, which we can make exactly, then we would just build our box with that center to center distance. The other thing we can do is to type in ERR equals, that gives us the error, because this is not an exact solver in general. It's use an iterative process, but you can see that's essentially 0. So anyways, that gives you an idea just with one equation. If you have a series of parameters, so in this case we had 5 parameters, we could pick any 4 and then find whatever the 5th one is using the equation solver. Next, want to just go over this problem right here, where these equations are actually the equations of equilibrium for a robot going up an incline with the drive wheels on the wheels in the rear. So the front wheels are going up the incline and the rear wheels are in back. And N sub A is the normal force on the rear wheels, N sub B is the normal force on the front wheels. The moment, this point K is actually at the bottom of the front wheel. So the important thing here isn't so much what it represents, although if you've done 1001, you've done a problem very, basically you have done this problem. And so these are the normal forces, these are the locations relative to the point on the bottom of the rear wheel to the center of gravity, the weight, the wheelbase, these is coefficient of friction, frictional force. So these are just parameters. You just have to start out with some values. Now notice that there's 9 parameters here and there are 4 equations. So that means you can solve for 4 unknowns. So you can pick any 5, give values to any 5, like maybe you know the weight, you know the coefficient of friction, you know the wheelbase, you know the location of the center of gravity, and then you can solve for the others. And so this would allow you then to maybe change your center of gravity if you want to see if you can change the angle and then just solve for the angle, or solve for the coefficient of friction that you need. So this wraps up this introductory video.